All right, guys, let's go ahead and take a look at our first representation of quantitative data. We've been doing the graphing of categorical data, and so now we're going to do the quantitative data. So we want to represent these numerical ideas graphically. What that does for us is that gives us a good way to quickly look at something and visualize the center, the spread, how the data kind of seems to be in one quick picture. It's good for comparisons. It's good for identifying that center and that spread, getting a general feel for the data. It's really good for large data sets. This box plot is what we're going to start with. And so let's just go ahead and go on into it. So, first of all, whenever you do a box plot, you have to make sure that you have the five key elements in the box plot. So, we're going to identify those. Those five key elements make up what's called the five-number summary. Okay? If you see the five-number summary written out, they'll typically write it from the numbers from least to greatest, and they'll say these are the five-number summaries. That doesn't mean that's the five pieces of data in this data set. That means that that is the minimum. So that would be right here where this is located, the minimum. The quartile 1, and we typically just call that Q1. Okay, and so that is that left side of the box. The next is the median. And so this median, of course, you've done in the past, that is the center of the data. If you put the data in order from least to greatest and you found the item that is located in the center. It is not the average, but the item that's located in the center. And then quartile 3, and we'll talk more about, what these quartiles are here in a second. So that quartile 3 is the top part of the box, okay? And then, of course, you have your max up here at the top. All right. So with that being said, let's kind of talk about some of the different qualities of what's happening here in this box plot. Now, first of all, because these are quartiles, what that is indicating is that in each one of these sections, so from the min to Q1, that is representing 25% of the data. Okay. And so then that means from Q1 to the median, that is representing another 25% of the data. So what that tells me is if I had 20 pieces of data, I've got 5 pieces of data in from the min to the Q1, 5 pieces of data from the Q1 to the median, and so on. So each one of these quartiles is indicating 1/4 of the numbers in the data set. Okay? Now, let's address why this median is not located right in the center when I told you that that is the center of the data. Okay, so we need to pay attention to the number of items, how many pieces of data. It is the middle item. So it is in the, like if this was 20, then here this is after the 10th piece of data. So you have 10 pieces of data on the left, 10 pieces of data on the right. Now, what we definitely want to look at is why is this part of this box wider than this other part of the box, okay? When they both contain 5 pieces of data, if this was a 20-piece data set. Well, I hope you can tell that the reason is because what's happening is, say if this was like the number 20, then this would go up to say 25. And so then the median being 25, this would just go up to say like 27 or 28. So the spread, you can tell how varied those 5 pieces of data are. So these 5 pieces of data in this second quartile, which is from Q1 to the median, is more varied than the 5 pieces of data in the third quartile from the median to Q3. Okay, so paying attention to that variability of that data set. This also is going to, the box plot can also give us an indication of the shape of the data, and we'll talk about that more as we go into talk the next lessons that we're going to encounter, talking about the shapes. All right. So again, we talked about how each of the boxes or the whiskers contain 25% of that data set, but we also need to talk about this thing called interquartile range. Interquartile range is a standard item or a standard label that you would say to represent how varied this data is. And that is because we would say the middle 50%. So the middle 50% is a good way of indicating where the bulk of the spread is and how spread out the data. So this is the interquartile range. It's a number. So say like 27 minus 20. So that would be an interquartile range of 7. So what you're doing whenever you do the interquartile range, and it's frequently represented as IQR, the interquartile range is equal to that distance, Q3 minus Q1. Okay? So, and you get a value. So you don't say the interquartile range is from 20 to 27. You say the interquartile range is 7. That is how spread out that middle 50% is. All right. Next, we're going to talk about what is considered an outlier. When do we start getting something that we say, whoa, that is way different from the rest of the data? Well, now we're going to start identifying that mathematically. We have just at this point talked about statistically significant and talked about significantly different from the rest of the data, but now we're going to put math to it. And I'm going to hold off on that for a second. When we go on to our next example and start graphing it, then we'll come back to this actual rule of the math to identify an outlier with the box plot. So here we go. This next page that you have is just kind of another visual. It gives a data set of 0 to 9. So it shows you that median. And so then, of course, this is showing equally spread out information. So that shows that median is right in the center. Okay, I guess 0 to 10 is another. Okay, so if you had an odd number of items, then here this median would be 4.5. Okay, so that median, if it falls in between, is you would average those two items together and get that median of 4.5. Okay, now talking about how to get this Q1. What your Q1 is going to be is you're going to take the bottom half of the data and find the median or the middle of that bottom half. So that middle of the bottom half of data will be your Q1. Okay? And likewise, the middle of the top half of data will be your Q3. So that's how you physically find what those other pieces of data are. Here's just another representation so you can see the box plot also written out, and there's your 5-number summary. So let's go ahead and make one. So here we have family interested in buying a new minivan. Karma is involved in mountain bike racing, so the cargo volume is very important when she's considering which minivan to buy. So here we have the following table. This is actually 15 pieces of data, not 2 different sets of data. So because our first step is we want to make sure we put our data in order from least to greatest, I've already done that here for you. I've already organized it. I have two 56.5s, a 57, 58.5, and so on. All right. So the first thing that we need to do is identify the 5-number summary items. Identify that minimum and median and all those kinds of things. So let's get started. Okay. We know that we have got our minimum at, that one's always easy to identify, at 56.5. Okay. We know we've got our maximum. That one's also easy to identify, that 103.5. Okay. All right. Now let's find the median. So one of the ways that you might look into finding that median, if I have 15 pieces of data, then I know that I need to split that in half, and that's going to be 7.5, or the eighth, that will end up being the eighth piece of data. I think of it as, 7 on one side, 7 on the other. That's split in half, and that 15th piece is that one right there in the middle. So if that doesn't register in your mind, then we can always think of it like this. I'll put a dot above these. So you have the top and the bottom, the top and the bottom. If you're knocking off these different top and bottoms, then you will eventually end up in the middle, and that will be your median. Okay, so there we have it. So that median is 73.5. Okay, so and so that's what I'm going to write here with our 73.5. Okay, now let's find the Q1. So what I'm going to do is I'm going to take this bottom half of data. Most of the time, and there's actually two different trains of thought. So some texts will include this median when finding that other item, when finding that Q1 or whatever. But we actually typically, our textbook didn't, and I don't think AP does it as well. So that's our median. So that means when I look at trying to find the middle for the Q1, I'm going to go like this. There's the bottom, and then 67 is the top of that bottom half. Okay, and then bottom and top, bottom and top, and then ding, 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 there I have my Q1 at 58.5. Okay, so that's how we identify that Q1. So you go ahead and try to find your Q3, which is the same process, just the top half. Okay, so go and try to do that. All right, so I found that to be this 75.5 right here. Okay, so let's go ahead and talk about the way that we are. Okay, so we can do the IQR. Okay, we know that IQR is that Q3 minus Q1. Okay, Q3 minus Q1. So that, of course, is going to be our 75.5 minus 58.5. And I think that equals 17. So there is our middle 50% is spread out 17 cubic feet, I think is what this was measuring. Okay. All right. Now, we're going to have to identify if we have got unusual amounts of data. Do we have an outlier? Okay. Outlier happens when the data that you have is for, and we're starting to do this now mathematically. So if you take a look at this page here, we can see that we have this rule here for the lower fence. Okay, so our lower fence is going to be our Q1 minus 1.5 IQRs. And we'll compute that here in a second. And our upper outlier fence is Q3 plus 1.5 IQRs. Those need to be memorized. And so because those need to be memorized, then guess what? I've got a song for that. So let's go take a look at our songs for Boxplots. I've got a couple of things going on there. So here I'm going to go to my stats song list. We're in descriptive data. And so here we go. We got the Boxplot song. And so let's go ahead and do that Interquartile Range song because it has the outliers. So here we go. Let's see if we can listen to that.
Interquartile range, the middle 50%. You use it to find the upper and lower outlier fence. lower outlier fence. It is Q1 minus 1.5 IQRs. Q1 minus 1.5 IQRs. Upper outlier fence. It is Q3 plus 1.5 IQRs. Q3 plus 1.5 IQRs.
Okay, I'm recording. So I'm just about done, and then I'll go on with that. Okay, so that right there is I hope that you're able to hear that. I didn't look at that ahead of time to see if you were going to be able to. But anyway, let's go on over here then and do that computing. So we're going to come here and I'm going to have you compute your upper fence, which is going to be your upper fence course is going to be your Q3 plus 1.5 times that IQR. Okay, so now if we fill in our numbers, then we're going to have that 75.5 plus 1.5 times that IQR that we said was 17. And I think that ends up being like 101, if I remember correctly. Not completely positive on that, so check my math there. Here we had the lower fence, which is Q1 minus 1.5 times the IQR. And so here we have 75.5 minus, oh, wrong. Hold on a second. I almost did that wrong. Q1 is 58.5. Okay. Minus 1.5 IQRs, which is 17. And I think, if I remember correctly from watching that data set, it's at 33. All right, so we have identified then our outliers, fences. And so now we want to come in here and we want to put this all together. And so let me pause this for just a second, take care of something here. And then we'll come back. We have a song for how to take care or how to do all of our recording. And so we'll take a look, how to do our plotting of our box plot. And so then we'll come together here in just a minute and actually graph that data set. Okay, so I hope that this you've been able to hear the song as we were playing them, because this box plot song is going to help you know the order in which you take care of items to be able to graph them. So here comes the box plot song. Here we go.
Scale box, fences, whiskers, scale box, fences, whiskers, scale box, fences, whiskers, put those outliers on. Scale box, fences, whiskers, scale box, fences, whiskers, scale box, fences, whiskers, label, label, label.
Okay, I hope it's playing for you and you can hear it.
Scale box, fences, whiskers, scale box, fences, whiskers, scale box, fences, whiskers. That's how you make a box plot.
Okay, so then let's go on here forward and let's make our box plot. So we have all of our data. And so down here we have a number line, and because we have to draw to scale. So that's why we want to make sure we have our scale, box, fences, whiskers. So our first thing is this. I see that my lowest number is 58.5. So I'm thinking I'm going to start this thing at 55. And I'm going to go up by fives. I think that works out. And so on. Okay, kind of hard to put these things in order on here. But anyway, you're probably able to write them out better. And then 100, 100, 105. Okay, not ideal. Did I 55, 60, 65, 70, 75, 80, 85, 90, 95, 100, and 105. Okay, so there's that. I think I'm actually going to shift this up here because maybe then I'm going to get my fence on. So, okay. Anyway, so scale, box. So let's put that box in here. And so what we do for the box is we're going to put that box right here from 58 and a half to 75 and a half. So we're going to put it above the scale, the number line. So 58.5 to 75.5. So I'm just kind of approximating what that looks like. Okay. Next, I'm going to put in my median. It is at 73.5. So that's right here. So, I've really got a lot of data clustered here together in a very small range in this quartile. Okay. So there's my scale and my box. So according to the song, we're going to go scale, box, fences, whiskers, scale, box, fences, whiskers. So we want to put our fences on. And these fences are really an imaginary line. So I'm just going to kind of real carefully draw this, a dotted line here at 101. Okay, so there's that one. And then 33, 50, 45, 40 is actually going to be somewhere way down here. Okay, so there are my outlier fences. And so we want to put those fences on because then that's going to allow us to, now we're going to put the whiskers, which is going to then go to the min and the max, with the exception of you cannot cross out over the fence, the outlier fence, with your whisker. So let me explain. First, let's look at the bottom side. Were there any lower outliers? A lower outlier would be something that is in this area below the lower fence. So a lower outlier is below the lower fence. And our low fence was at 33. Our min is 56.5. So no, we do not have any lower outliers. So we're going to go ahead then and put in our 56.5 and then make our whisker go to that. So there's the bottom whisker. Now, on the top side, however, we do have a number that is above 101. So that means we have got an outlier. And outliers are represented by a dot. Okay? And so what we're going to do is we're going to put a dot there for our 103.5, and we'll label it here in a minute. And this is very important because this is a very common mistake. Do not draw your whisker to the fence or to that outlier. No, the whisker goes to the next piece of data inside the fence. So in this case, that's 98. So I'm going to put the top of my whisker at 98, and there that is. That is our box plot. Now, of course, we've got, that's how you make a box plot, but we do need to make sure that we are labeling those. And what I usually do is, and I don't know if I can do this fast enough for you, but I'm going to put this here. I put the numbers on one side, and then I label that as that's the minimum on the top side. So on the top side, I'm going to put min, and that this was my Q1, and that this was my median, okay, and then that this was my Q3, and so on. Okay, so I'm going to label like the labels of what those are called, and the max is over here. Okay, but then underneath it here, that's where I'm going to put the numbers. So my 73.5 is that Q1. My median was 75.5, and so on. Okay, so I am then labeling those. It's kind of hard to squinch this in here. So so what's going on? Oh, I put the wrong, looky there, I did put the wrong things, right? That's 58.5. Okay, and then this was my median was 73.5. Okay, so now we're good. And then my Q3 was at 75.5. And then now I am going to go ahead and label where the top of my whisker is. Okay, because I don't like things floating out there without telling me exactly where those are. So there's the top of my whisker, and then there's my 103.5. Now, you can also label where the fence is. So I know that my fence was at 101, okay, and that this fence here was at 33. So there's really no doubt where all of these items are, where exactly everything fell, it's labeled, and we can do all of those. That is how you complete a box plot. All right, so I hope that that is good for you. We're going to do this 4 box plots, but I do want to let you know that once you get to problem number 3, it's a large data set, a pretty large data set where you don't want to have to go through and find all of that in the 5-number summary. And number 4 is even worse. It's got even more numbers. So once you get to number 3, the next little video and this step-by-step instructions here tells you actually how to utilize your calculator to get the 5-number summary. Okay, so how to let the calculator compute the 5-number summary for you, which might be a lot easier than you doing it by hand. Okay, all right, so there is your box plot making of our first graphical display of our quantitative data.